All right. In this video, we're going to explore the technique of U sub with integration. So U sub is just a technique that helps us solve more complex integrals. For example, as we can see on question 1 here, instead of foiling it out and, doing that 9 times, well, instead we can, as we'll share in a second, we can take a U sub and it'll make the process a lot easier, okay? So U sub just makes the process of solving integrals a lot easier. Okay, so let's go ahead and get into this first problem here. So we have the integral 4x minus 3 to the 9. So what we can do is usually you like to look inside the parentheses of a number to a particular large exponent. So what we're going to take is we're going to take the 4x minus 3 and count that as our U sub, okay? So then we're going to write du over dx, and that's going to equal the derivative of u, which is just going to be 4, okay? And now what we can do is we can multiply the dx to both sides, right? And this part's a bit tedious, but we won't do it after this problem. And so you're going to have the dx now on the right side, and then we could divide by this 4 right here, and then what we're going to have is the du over 4 equals dx. So we just replace this dx right here with this guy, okay? So now let's see what this looks like when we have the u sub in this place right here, okay? So let's rewrite this integral. Let's rewrite it with our u sub. So we're going to have integral u to the 9, and then instead of dx, we're going to have this du over 4. Sorry about my handwriting, that doesn't really look like a 4, but it is, I promise. Okay, so now we have this. This looks a lot better, right? We know how to work with this if we've worked with integrals in the past. So what I would do in this situation is I would take out the 1/4. Okay. Take that out, and then we have a u to the 9. And now what we do from here, I should not forget the du. Sorry about that, it got all big on me. Don't forget the du because we still need to integrate. And now what we can do is we can take this 1/4 times, this is going to be 1 over 10 u to the 10. And then that's going to be, that's going to come out to 1 over 40 u to the 10. Now this is a very important step right here. What you want to do, because we've used our u sub, right? We want to plug this number back in at the very end. We want to plug this back into our u at the very end. Okay, so what the final answer is going to be is 1 over 40. I think it was 4x minus 3. Yeah, let me zoom out a little bit. 4x minus 3, 3 to the 10. So that's going to be, sorry about that, screen just flipped. That's going to be our final answer. So see, all we did was we substituted what was inside the parentheses, 4x minus 3 to the 9, and we made that a u to the 9, and we know how to work with that. And then we just did this right here. This could seem a little, this stuff might seem a little weird, but all we're doing is replacing the dx with the du, okay? So that the u matches the du. So we have our variables matching, I should say. And I'm going to show a problem in a second where it's a little bit more difficult to match the variables. But let's do one more that's a little bit harder, but in the same ballpark as this one, as far as the concept. So let's go ahead and do Let's do this one. You're going to hate me for this one because we got our trig functions. We love our trig functions. We love them. Okay. So we have this integral, secant 4x, tan 4x, okay? Now, sometimes on these problems, when you're doing a u sub, you may not know which exactly the correct variable or trig function or number to u sub. Usually, again, you're going to do what's inside the parentheses. On this problem, there are no parentheses, okay? So sometimes you just have to trial and error. Sometimes you just have to go for it, and you may end up going down the right path, or you may end up going down the wrong path. In this particular problem, let's go ahead and let's try to make our u sub 4x, okay? Let's make our u sub 4x. And if we do that, we're going to end up with du over 4 is going to equal our dx, okay? So let's rewrite the integral. Let's rewrite the integral. And so we're going to have secant u tan u du over 4. So this is going to be kind of similar to the previous problem we just did, as far as we're going to take out this 1/4 right here and put this in front of the integral. And now we have something that may look familiar to you. This may look familiar to you. Secant u tan u, imagine if that was an x. Secant u times tan u is secant u. That is the trig function for that, is secant u. That's the trig function. Now, remember, we need to plug back in the original x value, right? So what this is actually going to be is 1/4 secant 4x. And I forgot something on the last problem, plus c. That is going to be the answer. And so this one too, bad math. There should be a plus c in there, okay? I apologize for forgetting that. My teachers are very strict about that, so imagine yours are too, so don't forget that. Okay. Now I want to do one that's a little weird, okay? This one's a little weird, and you're going to see why in a minute. Especially if you're semi-familiar with u subs, you are going to find this problem to be weird, okay? So here's what we're going to do. We have the integral y over root 2y plus 1. This is what I'm thinking. Let's make u equal 2y plus 1, okay? So it's going to be du over 2, okay? Let's rewrite the integral. You may already see what's going on here. If we rewrite the integral, we're going to have y over root u du over 2. Now, can you see what the issue is? Sorry, my du looks horrendous. Let's fix that up. Boom. It's beautiful now. Can you see what the problem that we are running into? Notice we have two different variables going on, which is not good. We have u and we have a y. We need to somehow get this y on terms with the u, okay? In other words, we need to set this, we need to solve for u with this equation. Okay, so let's do that. Let's solve for u with this equation. Let's subtract 1 from both sides. Let's divide by 2. And so that's just going to be u minus 1 over 2. So now we can replace this y with this. You can plug that in right there, okay? So sorry, this is really messy. Let's get this organized a bit. Integral u minus 1 over 2 over root u du over 2. Okay? Now, I just realized this problem is similar to the other ones too. That's so funny. How ironic. What I'm going to do right now is I'm going to take out another 1/4. Because if you multiply these two guys together, you get 4, right? 1/4. And we could take that out, and look what we'll have. This will make this much easier. We're going to have root u du. Boom. That's just random coincidence that we happen to pull a 1/4 out every single time. That's crazy. Okay. So now what do we do? Well, whenever we have situations like this, where we have something being added or subtracted and it's over one thing in the denominator, what I like to do is separate it. I like to do this. U over root u minus 1 over root u du. And so what we can do here is really quick. You know what we can do with the square roots, right? We can go u over u to the 1/2, right? 1 over u to the 1/2 du, okay? And then once we do that, well, this is technically u to the 1. That's actually going to become u to the 1/2, right? Because 1 minus 1/2 is just 1/2. So this is going to be 1/4. We're going to have u to the 1/2 minus, and then we're going to bring this up actually. So it's going to be to the negative 1/2, right? Because if we flip an exponent, it becomes negative, okay? We still need to integrate these, so we're going to put the du. Now, let's integrate. So we're going to have 1/4 times, this is going to be 2/3 u to the 3/2 minus, this is going to be 2u to the 1/2. And all I did here, sorry, I just did that in my head. I could have shown that better. Was we did, right, what we have is 1 over 1/2 plus 1, which is going to give you 3/2. And then if you flip that, you get the 2/3 right here. And then the exponent is 3/2. And I did the same thing for the other one. It was 1/2 on the bottom. And then I flipped that and I got 2. Okay. Now, let's see. This looks really sloppy. I'm sorry. So we integrated, but there's also something else we're going to have to do. Let me just write this out right here so it looks better. 1/4 times 2/3 u to the 3/2 minus 2u to the 1/2, okay? And we're going to have to distribute that. So we're going to, if we distribute this guy right here, you're going to get 2 over 12u to the 3/2 minus, that's going to be 2 over 4u to the 1/2. And I'm just going to write this right here so we don't forget, plus c. And we're not done yet because we still, excuse me, need to simplify it. And so once we simplify it, we'll have 1 over 6 u to the 3/2 minus 1/2 u to the 1/2 plus c. And we're still not done yet because we need to bring the original u back in. We need to bring in this value right here, the 2y plus 1. So we're going to have 1 over 6 2y plus 1 to the 3/2 minus 1/2 u oops, not u, minus 1/2 2y plus 1 to the 1/2 plus c. And that is your answer. So yes, u subs are very helpful for solving more complex integrals. And yeah, just make sure to plug in the x at the end, like what I forgot to do. And then make sure to put this damn plus c. Don't forget the plus c. Don't do it. I've done it many times. Don't do it. It's hard to forget. I know. Just try not to. I hope you enjoyed this video. Thanks for watching. Peace.